Hi, we're continuing on with the slope calculations. You should have already seen video 1. Remember that I'm going through the completed notes and you have a blank copy, and I strongly suggest that you take the time to do your own calculations on the blank copy and then compare it to the filled out copy. And now we're going to start thinking about the slope from a function. So in this first example, this function doesn't mean anything in the context of the real world. It's just some random function. But what I'm showing you here is from a function, you're familiar with creating a table. It doesn't matter what values you plug into the domain. As long as you calculate the output, the range values correctly, then you can use any 2 points to calculate the slope of that function. So in this case, I used these 2 points and I ended up with a slope of 1/4. And remember, this is a y value, this is a y value, this is an x value, this is an x. So I did y minus y, x minus x, going in the same order. So if I went from here to here, I need to go from here to here. And one thing you should notice is you see this answer of 1/4 for the slope, no matter which t-chart you use. That 1/4, by coincidence, not really, it's not a coincidence, matches this 0.25 because 0.25 equals 1/4. The equation many times is telling you what your slope is going to end up being. So in the next example, we end up with an applied scenario. Here we have, you should take some time to read this example, so I'm going to go ahead and pause this. Actually, you should pause this and read the example. And what we have here is a scenario where we have 20 centimeters of water, but it's increasing at 3 centimeters per hour. We're 20 centimeters above the normal water level. So in this scenario, the words lead to this function. This function leads to this table and or this graph. And the graph shows that the water level is rising over time. So if you wanted to find the slope of this, you could possibly do rise over run with 2 points that you got from your t-chart, or probably more likely, you'll choose any 2 points. I chose 0, 20 and 6, 38, and you do your y minus y over x minus x. But the point here is you get a slope of 3, whether you do rise over run or y minus y over x minus x, and that 3, by no coincidence, was in your equation, because slope is a rate of change, and in this case, the water level is increasing at a rate of 3 centimeters per hour. So the lesson to learn here is a rate of change of a scenario, which shows up in your equation, is also going to be the answer for your slope. So the rate of the rising water, 3 centimeters per hour. The slope of the graph, 3. The slope of a function means something in the scenario. I've moved on to the next page, and you should pause the video and read this quick little scenario. And we can see that the oven is at 200 degrees and it's heating up 8 degrees per minute. That's a rate of change. So that's going to be a clue about the slope. But if you go ahead and take those words, turn it into a function or an equation, turn that into a table, turn that table into a y minus y over an x minus x, you get a slope of 8, in this case 8 degrees per minute, which, as you figured, is the rate at which the oven is heating up. This final example down here, again, pause the video so you can read that example. And we have a rate of change. In this case, it's a depreciation per month of your car's value. So you can turn that into an equation. $12,000 minus $200 per month is the value remaining on your car. Well, if you recognize this minus 200 as the rate of change in the scenario, then you already know the answer for your slope. If you don't recognize that, you take your function, you make a table, you do your slope calculations, and you're going to wind up with a slope of negative 200. And in this case, I should put a negative on there because it's decreasing by $200 per month. So the lesson on this section of the notes is when you have a scenario, you're probably able to spot the slope as part of the scenario. But if you can't, do the math and you will end up with a slope value. That slope value should also probably mean something to you, or you should be able to find it within that scenario. I'm now going to move on to the very last section of notes. And in this case, we're going to hit some things that you probably have already picked up on as we went through. The first thing to reiterate is if you have a linear segment, then it doesn't matter what points you pick, the slope is going to remain the same from point to point to point. So if you chose those 2 points, you get a slope of 3. But if you chose those 2 points, you get a slope of 3. And you could keep choosing different pairs, but it's always going to be the same slope over and over. So I'm going to branch off the notes for a second, and instead of looking at a graph, we're looking at a table. And the question is this data from a linear function? Well, to find that out, you would have to find the slope between these 2 points and the slope between these 2 points. And if there were more, we'd have to keep going and doing that. If it's linear, then the slope is always going to be the same between any 2 points. So I went ahead and did the calculations for you, and it turns out between the first 2 points, the slope was 3. Between the second 2 points, the slope was 2. You can see my calculations over here. But the fact that already I've arrived at 2 different slopes tells me that this line, or sorry, this curve, this function, is not going in a linear manner. Looks like it was starting out pretty steep, and then as it traveled, it got a little less steep. So maybe at this point the slope was 3, and at this point the slope was 2. Whereas if it were truly a linear function, the slope would be the same the whole way through there. Another shortcut you have for slope calculations is you should be able to tell just by looking at a graph whether the final slope answer is positive or negative. This line's going uphill, so it's a positive slope. This line is going downhill, so my answer for slope would be negative. And the key to reading a line is just as your eyeballs travel from the left to the right when you read a sentence, you should travel from the left to the right as you read a line. So here's the left edge of this line, and as I travel to the right, this line is going downhill. So always have your eyes scan from the left to the right, going uphill, positive slope. Scan from the left to the right, going downhill, negative slope. And finally, on the back page of these notes, we've got 2 kind of unique cases. If a line is horizontal, you can just memorize that it has a slope of 0. But if you don't like memorizing that, then go ahead and choose any 2 points on that line. I know it's hard to read those points, but I have them written down here. If I take those 2 points and do y minus y over x minus x, I get a slope of 0. When a line is vertical, you can memorize that it has what we call an undefined slope. We will sometimes use that symbol for it. But if your memory fails you, then just take any 2 points on that line, any 2 points at all. I chose these 2 points, and by carrying out my y minus y over x minus x, I got a 3 divided by 0. And if you go to your calculator and do 3 divided by 0, big explosion. Your calculator will tell you error or something like that. That leads to an undefined slope. So Don't mix up 0 divided by 4 equals 0 with 3 divided by 0 means undefined. Go to your calculator and let it tell you if you don't trust your memory. And if you have a great memory, you just always know horizontal lines, slope of 0. Vertical lines, a slope we call undefined. And then what you should notice at the bottom are examples of functions that are curvy, not linear. And with these style functions, you'll notice that we don't do any slope calculations because these slopes, or the steepness of the graph, is constantly changing. So if it's constantly changing, we can't come up with a specific slope calculation. Notice that every example of slope calculations that we've done have involved a linear segment, not the nonlinear segments that you see at the bottom of that page. All right, that's a lot of slope information between those two videos, but it's all relatively attainable and easy. See you later.